Okay, so good day everyone. So this is the continuation of our discussion in our radiographic film. So this is chapter 2. So we will discuss the radiographic technique factors, but most of the discussions, most of the topics here are already familiar to you because we have already tackled this in our previous lesson. So we will start first. We will be discussing radiographic technique factors, which include the KVP, the MA, and the time. So I'm sure you are all familiar with that because, as I have mentioned, we have already discussed this before. So we will start with the MA or the milliampere. So take note, it is written in small letter m because it is milli. Because if capital siya, it would be mega. Okay, so capital letter A for the ampere. So MA is a unit of charge. So for example, the unit of electron charge or electricity can be expressed in ampere or milliampere if there are small values. Okay, so also MA represents the current flow through the cathode filament at the time of exposure. So this is the amount of the current flowing at the filament which can be found sa cathode of the X-ray tube during exposure. So basically, when there is an increase in milliampere, there will also be increased in the number of X-ray photons produced in the X-ray tube. So ibig sabihin, kapag nag-increase tayo ng milliampere together with time, so we will also be increasing the amount of electrons produced in the filament. And during the discussion sa ating radiologic physics, so MA and time or the MAS is responsible for the production of electrons in the filament. So when there is an increase in MAS, the number of electrons will also increase. And because there is a proportional relationship between the number of electrons produced in the filament and the number of X-rays produced sa cathode, so therefore, number of X-rays will also increase. So again, kapag nag-increase tayo ng MAS, mag-i-increase din ng number of electrons produced sa ating filament, sa cathode, and the number of electrons produced from the filament will be transported to the anode. So, ang anode will convert the electrons into the X-ray photons. So, proportional. So, mag-increase ang number of electrons, there will also be an increase in the number of X-ray photons produced. And when there is an increased number of X-ray photons produced by the X-ray tube, specifically from the anode, there will also be an increase in patient dose. An increase or decrease in MA is represented by a quantitative factor. So we can quantify that and we can select that factor sa ating control console. So it is important to understand that an increase in MA does not affect the energy because the energy of the X-ray photons is only affected by the KVP, which we will discuss later. The purpose of increasing MA is to increase the number of electrons, as I have mentioned earlier. Number of electrons available to travel from cathode to anode, and that is proportional to the number of X-ray photons. So normally, when we select the MA, we will also select the time. But there are modern X-ray control consoles today that when we select the MAS, we don't need to select them separately. So the MA and the time are already calculated automatically. But in some old units, we should select milliampere, and we should also select the time. So exposure time is the factor that controls the length of exposure. So basically, when we say time for the technique factors, it refers to the uh, amount of time that the patient will be exposed to radiation, or the amount of time that the X-rays will be emitted from the tube towards the patient. So it is also a quantitative factor which can be selected through the control console. So when combined with MA, the time and MA determines the exposure rate. So when we say rate, that is over time. So meaning, when we talk about exposure rate, the amount of exposure received by the patient for a specific period of time. So to calculate for MAS, we simply multiply the milliampere and time. So that will result to milliampere seconds, as you can see there in the notes. So for example, we select 50 mA or 50 milliamperes, and the time is 1 over 10 seconds. So we multiply 50 times 1 divided by 10. So MAS is 5 milliampere second. So it is not milliampere per second ha. It is milliampere second. Ito siya. An increase in MAS, as I mentioned, increases the amount of electrons, which in turn will also result to the increased number of photons exposing the patient and the IR, or the image receptor. Since they are multiplied, the MA and the time, they are inversely proportional. So meaning, when MA increases, the time must be decreased. Because if you're going to increase MA and at the same time increase the time, so it will result to unacceptable exposure. So when you increase the other factor, you should decrease the other one. Because MAS is considered as one value in the selection exposure, so the two factors relate to one another inversely. So, ito yung sinasabi ko because they are group together, MA times time. So, they are inversely related. So, we have already discussed the relationship just like before. When they are on the same side of the equation, they are inversely related. But when they are on the opposite side, they are directly related. So this would be necessary to maintain the same exposure and essentially the same amount of blackening on the film. So bakit kailangan pag nag-increase ka sa MAS, kailangan mag-decrease pag nag-increase ka sa MA, magde-decrease ka sa time, or vice versa. So this is to ensure that you will still have acceptable optical density. Because again, just like what we have discussed before, inuulit-ulit natin to, the MAS controls the optical density and they are directly related. When you increase the MAS, you will also have an increased optical density. Okay? So another formula is MA and time relationship. So sabi ko kanina, they are inversely related. But there are some problems, especially during sa board exam, that you are going to predict or to calculate, hindi predict. You are going to compute for the new MAS or the new MA if there is a change from the old one. Like sa time, Sa old time, sa new time, or sa new second, sa old MA, sa new MA. So 1 here, sub 1 represents the first or the original exposure or the old one. And sub 2, S2 and MA2 represents the factors for the new exposures. So we will not compute more on this because yun nga, mahirap siyang i-discuss kasi sa online tayo. But anyway, so God willing, we will have our face-to-face class. So we're going to discuss more on this. But to have an overview, so let's have an example here. A radiograph is made with the following factors: 200 mA, 0.2 seconds, and 90 kbp. So that is for the first exposure. For the second exposure, so the new MA is 500. So meaning this is the old MA. This is also the old time. So the kbp here is parang pampagulo lang siya. So hindi tayo magko-compute using the kbp. Instead, we will compute for time kasi yung hinahanap is time. So we will use this formula. Okay? So we have here 200 for MA1. Ito siya. Lipat natin dito. Then 500 for MA2. And then we have here a missing new exposure time. So this is S2 and this is the S1, 0.2. Okay? So para hindi mahirap, let's transfer to this one. So our formula is MA1 over MA2 is equal to S2 over S1. Okay? So this is time, ang S for second, MA for milliampere. So ang MA1 is 200 MA. Ang S1, where's the eraser? Hindi ko makita. So S1 is 0.2 seconds. 0.2 second. MA2 is 500 MA. And we are looking for S2. Okay, so we will substitute. So, para mas madali, ito, we will cross multiply. So, this is also equivalent to MA1, S1. Diba sabi ko, they are inversely related. So, they are on the same side, they are inversely related. Is equal to MA2, S2. So, we are looking for S2. So, ang mangyayari is MA1, S1 over MA2 is equal to S2. Or, pwede natin baliktarin, S2 is equal to MA1, S1 over MA2. So we will now substitute. So MA1 is 200 MA. Then time is 0.2 seconds divided by MA2 which is 500 MA. So cancel. Para ang matitira is seconds. So 200 times 0.2, that is 40. Right? Wala akong calculator dito. Tingnan natin is 40, correct. So this is 40 seconds divided by 500. 500. So 40 divided by 500 is 0.08 seconds. 0.08 seconds. So, yan yung ating calculation, sample calculation for MA and time. Again, this one is the same with this one. If you can still remember our inverse square law sa intensity and distance, so the same din siya. So, we can write this one into this one para mas madali ang pag-transpose. Okay, so let's go back. So, the MAS, so this is the combination of our MA and time, controls the density as I have mentioned. So, controls the number of photons in the X-ray beam. Actually, this controls the number of electrons, which will result to the number of photons. Okay? The MAS and density directly related, as I have mentioned. If you increase the MAS, your density will also increase. If the MAS is doubled, the density will also be doubled, again, because they are directly related. If the MAS is reduced by 1/2, of course, your density will also be reduced. So if the MAS is increased, the film will receive more exposure, therefore, increased ang density. So next, the sensitivity spec or yung ating sensitivity center sa emulsion will attract more silver ions, and when the film is developed, so it will increase also the density. So this is why kapag nag-increase ng MAS, dadami ang X-rays na mapuproduce, so dadami rin ang sensitivity spec na mai-expose sa ating emulsion, so madaming part na maitim sa ating radiograph. So to see a visible change in density, one must increase the MAS by at least 30 to 35%. Okay? Kapag gusto nating mag-increase ng ating visible change sa density, so kung gustong dagdagan, ang ating density, so we have to increase our MAS by 30 to 35%. Another factor is the focal spot blooming. So the focal spot blooming is a kind of artifact that can be seen sa image natin. So the MA and the KB selections may affect the function and size of the focal spot. When we say blooming, it is an effect that increases the actual focal spot size when the tube current increases. So therefore, mag-occur ang focal spot blooming if there is an increase in the tube current or the tube current or ang ating MA. So, significant increase in MA will also produce focal spot blooming. So, para ma-avoid natin ang focal spot blooming, we should use lower MA. So, blooming caused by high tube current may affect the radiograph adversely. So, in order to reduce focal spot blooming, so we should also reduce the MA and increase the KVP. So, ang focal spot blooming, parang ganito siya. Okay. So, if this is the actual focal spot, so parang may mga shadowing, may silhouette siya rito. So, hindi na magiging clear ang ating image because of the focal spot blooming. Another factor that affects the radiograph is the distance. So, I have also discussed this last time sa previous video natin, yung ating recommended SID. Okay? Kapag hindi nasunod ang recommended SID, so pwedeng mag-suffer yung quality ng ating image. Then, ito yung mga nabanggit ko na rin last time. So, recommended SID. Next is the inverse square law. So, na-discuss na rin natin ito sa ating physics. So, this shows the relationship between the intensity and distance. So, there is a inverse relationship between inverse square law, inverse relationship between the intensity and distance. So, ang ibig lang sabihin nito ng inverse square law is that if you increase the distance, ito siya, for example, if you increase the distance from 40, ginawa mo siyang 100. If you increase the distance, so the intensity or the radiation dose received by the patient or the exposure will decrease. If you decrease the distance, like from 100, ginawa mo siyang 40, it will increase the intensity. Intensity meaning the exposure or the amount of X-rays reaching the patient and the IR. Siyempre, para rin siyang water gun. So, pag may water gun ka, tapos malayo ka sa kalaban mo, so, konti lang yung tubig na aabot sa kanya. Parang hindi siya gaanong mababasa. Pero, pag malapit ka naman sa kalaban mo or sa kalaro mo, mababasa siya. Okay? So, increase dahil maraming tubig ang mapupunta sa kanya dahil malapit ka. So, ito yung essence ng ating inverse square law. If you increase the distance, the intensity will decrease. If you decrease the distance, the intensity will increase. Okay, so we will not solve for this. Nagawa na natin to sa ating rad physics. Then we have the MAS and distance relationship. They are MAS1 over MAS2 is equal to D1 squared over D2 squared. So the formula shows a relationship where MAS needed for an exposure is directly proportional to the square of the SID or the distance. So they are directly related. So as the distance is increased, the MAS must also be increased to maintain adequate blackening of the film. So MAS 1 over MAS 2 is equal to D1 squared. Tama ba? Let me check. Tama. Over D2 squared. Or we can write this as MAS1 D2 squared is equal to MAS2. Bakit dito? Sana yung eraser. MAS2 D1 squared. So they are directly related. So ang intensity and distance squared, they are inversely. Ang MAS and distance squared, they are directly. Ang MA and time, they are inversely. Okay? So, ito yung tatandaan natin, yung kanilang relationship. So, sa MAS, they are directly related. Kapag nag-increase ka ng distance from 40 to 100. Increase distance will also increase the MAS. Dapat. So, kapag nag-increase ka ng distance from 40 to 100, for example, yung MAS mo is 5, you should also increase this. For example, hindi ako magko-compute. For example lang, from 5, pwede siya maging 7, pwede siya maging 10. But if you like, we can calculate. So, ang gusto ko lang ipaintindi is that, to ask me to calculate, you can say something like, what is the tangent of 90 degrees? Or, ang gusto ko lang ipaintindi is that, kapag nag-increase kayo ng distance or ng SID, like from 40 to 100, centimeters, dapat kailangan nyo rin mag-increase ng MAS. Okay? Bakit kailangan nyo mag-increase ng MAS? Kasi kapag yung MAS nyo will remain as 5, so halimbawa, gamit mo is 40, SID, gumamit ka ng 5 MAS. So, next, lumayo ka ng konti, ginawa mo siyang 100 centimeters. Tapos, yung gagamitin mo pa rin is 5 MAS. So, dahil malayo ka, yung ibang photons, yung ibang X-ray photons, hindi na makakaabot sa IR or sa patient. Kasi marami na siya, medyo malayo na yung ita-travel niya. So, kailangan mag-increase ka rin ng MAS to compensate for the distance. Okay? So again, if you increase the MAS, you have also to increase the distance. Or, if you increase the distance, you have also to increase the MAS to compensate for the distance. Okay? Sige. Ito yung mga example, so we will not calculate for that. Discuss ko lang siya. So, next is for the KVP. So, na-discuss ko na rin to, controls contrast, they are inversely related, controls also the penetrating ability, controls also the energy. So, ito yung sinasabi ko last time kung bakit medyo nagtagal tayo dun sa introduction sa mga relationship. So, para pagdating natin sa mga discussions na ganito, madali na lang. Hindi ko na siya kailangang ulit-ulitin or i-explain ulit because I am expecting you na naintindihan nyo na siya dahil paulit-ulit natin siya na-discuss nung introduction natin. Okay? So, sa KBP meron tayong 15% rule and 5% rule. So, erase ko muna to. So, we have 15% KVP rule and we also have 5% KVP rule. So, if you want to see a visible change sa optical density, you have to do the 15%. You have to follow the 15% rule. So, pag slight change lang ang need mo sa OD or sa optical density, you need to apply the 5% KVP rule. So, when we say 15% KVP rule, when you increase the KVP by 15%, you need to decrease the MAS by 50%. So that you will have an acceptable optical density. Basta itong pares niya, 15% KVP, 50% MAS. If you decrease KVP by 15%, you have to increase your MAS by 50%. Okay? Inversely related ang KVP at MAS. Dito naman, sa 5%, so konti lang yung change na gusto mo, If you increase the kVp by 5%, MAS should be decreased by 30%. Okay? If you decrease kVp by 5%, increase MAS by, 30% MAS. Okay, tandaan, 15-50. Ito, 5-30. So, that is the general rule. Okay? Again, inversely related ang kVp at MAS. If you increase the kVp, decrease the MAS. So, pag 15%, 50 ang pares. Pag 5%, 30 ang kapares na MAS. So, 15% ina-apply if you want to have a visible change in optical density. 5% ang ina-apply if you have or if you want a slight change in the optical density. Okay, so na-discuss ko na siya. Scatter radiation, produce more fog. Discuss ko na ito. Ito na yung 15%. 15%. Na-discuss ko na rin. So, take note. Ito yung importante. kVp is inversely related to contrast. kVp is directly related to density. Na-discuss na natin yan sa introduction. kVp has an effect on both contrast and density. Inversely sa contrast, directly sa density. Also, kVp affects the quality and the quantity. So, quality, yung kanyang energy, directly related. Quantity, dami ng X-rays, directly related din. Okay? Lagay natin dito. So, increase kVp, decreased contrast. Increased quality, or ito yung ating energy or penetrability. Also increased quantity or ang dami ng X-rays, and also increases optical density. It also increases energy or the penetrating ability. For MAS, if you increase the MAS, you will also increase the optical density. You will also increase the quantity. So, other term for quantity, exposure, intensity or number of X-rays or X-ray photons. So, the same lang na quantity, exposure, intensity, number of X-rays. So, if you have noticed, ang kVp marami siyang ina-affect. Affected ang contrast, ang optical density, ang quantity, ang quality, ang energy. Ang MAS, optical density lang at quantity. Okay? Ito siya. Take note, MAS does not affect contrast and the quality. Only the density or the quantity. So that's it for chapter 2. Okay? So if you have questions, so you can message me so that I can explain it further to you, or if you have concerns, feel free to message me. Okay? So sa next natin na discussion, I will discuss chapter 3. So thank you and good day everyone.